Okay, so this is our example of virtual functions and polymorphic behavior. On this line of code, by the way, that's where we try to focus our attention and try to make everything possible to dispatch virtual calls to individual functions. So let's continue with our presentation and just talk about all the principles. So runtime polymorphism in C++ uses inheritance. Yes, this is true because what we do here is, if I resize this, of course we use inheritance. The virtualization of functions is not possible without inheritance. You already realize that this is how things are dispatched through inheritance. Now, so polymorphism allows us to redefine common functions and derive types. So it's like we provided multiple versions of print in different classes at the derived level. We can construct objects of specific derived types, which we did right here, right? So we constructed different kinds of objects that we try to use in our dynamic example. We maintain these objects via pointers or references to the base type. Right here, this is the base, okay? So this class, customer, we chose it to be our base class. So here we are deriving from this base class all the derived classes. Call common member functions on these pointers or references, and that's exactly what we do on this line, right? So we use pointers to call our functions, and C++ will redirect your calls to the real types of objects. And the real types, of course, are these two, the company and the person. Okay, so we're talking about the actual implementations with specialized versions of print, and that's what we, of course, observe when the program executes. So this is yet another example with shapes. The idea here is that there is a shape. It has virtual draw. So we used print. This one is talking about drawing some sort of shapes. And here we have the virtual. I repeat this virtual keyword in all of these. But as you can see, you don't have to repeat this keyword in derived classes, as long as you declare it once. And here, an example is that we're using a virtual function called draw through the shapes. In this case, shapes is just an array of pointers to shape, and we have 100 of them. And we populate this shape with multiple shapes, and pretty much so it's doing the same thing. In our case, we've used vector like this instead of this raw C-style array of shape objects. And of course, again, this is an array of pointers to the shape. So it's exactly the same as we did over here, but I think you know, you can try to copy and paste this and experiment with both of these examples and see if you can make it to work, and see if it works on your machine. Okay, so if it's just a quick observation that if the virtualization of functions was not available, what could be our alternative? One, possibly there could be multiple alternatives. One part would be to basically create an enumeration of different types of objects that we want to maintain in our hierarchy of objects, and maintain a single shape, right, or a single customer with specialized version, like, you know, different names for these functions for each. Basically, you would have to throw all of this into a single class, right, and there basically switch on the shape type or the customer type, and that would be that would be the alternative to using virtual functions. Okay, but this alternative really is not very attractive at all. All right, so here, if we wanted to add new type of customer, okay, like some kind of non-profit organization, all we could do is just to copy and paste an existing definition and tweak it to work correctly for non-profit organization, adjust all the operations, and nothing else would have to change here. We just create the objects that we like, and we still use the same logic to push back addresses of our objects, so there will be new objects that we can insert into this vector of customers, and we can and this code would not have to change at all. It'll work perfectly fine. All we have to do is just like add new structure, make sure that we derive it from the same common base, and it starts to function exactly the same way. So we have some kind of custom enumeration of constants, and now we have the switch statement, and you have to chase every case that corresponds to these types. It just makes maintenance very difficult, and overall it's not clean at all. It's all sort of like, you know, thrown into one place where all this logic has to be resolved. And then with an example of a shape, if we deal with circles and squares, if we go just back to for 1 second, we actually have circle has the radius, and square, or for instance rectangle, would have width and height and things of that nature, right? So if we don't have individual classes dedicated to specific data types that we want to use in the system, it would be very difficult to arrange the names of these functions, where they should reside, how they should be called. Here, look how uniform this print becomes, right? So we define a virtual function print, and then we specialize it for this type of object, specialize it for this type of object, and everything is just straightforward and very very clean. It's just so easy to follow the logic here, right? So we start here, we can have an implementation at this level, and then we define this print or anything else as just the way we want. So, and by the way, also, your approach to doing your own decisions at runtime will be simply slower. So don't think that you could write some code which is not using inheritance and which is not relying on virtual functions. However, it could, right? So we say that the hierarchy of objects and using virtual functions would be correct possibility in your case, but you're thinking that you could optimize it somehow and make it run faster. It's just absolutely not guaranteed that it's going to be faster or better performance. All right, so all of this we already observed in the code, and it's interesting that here we say that descendant classes, right, such as company or person derived classes, could avoid using virtual. And on this slide a while ago, I recommended using the virtual label with these functions, right? So we just say, you know, we can just add this right here. But it seems like the latest discussion on this style tends to go and say, don't do it, okay? So because it just makes the rest of the interface or implementation cleaner, okay? So it's up to you. You could use virtual keywords right here.